you, and good morning, everyone. Our team is delighted that we're one of the recipients for this important grant, and I'm also very excited that I get to share with you about our project, A Pathway to Preventing Leukemia. The project came about because of our vision. Our vision is bold, that one day we could prevent leukemia, and this is important. So the incidence of leukemia is increasing. As you can see here on this graph, obtained from the Australian Institution of Health and Welfare, and it's the blood cancer incidence, as you could see, it's uptrending. It's the same statistic that's projected come the year of 2035, that blood cancer is going to be the most common and also going to be the most fatal cancer in Australia. And leukemia is one of the main types of blood cancer. Leukemia can arise spontaneously or secondary to chronic bone marrow disorders. And today, there are about 50,000 Australians living with chronic bone marrow disorders. They have overactive bone marrow. The bone marrow looks like this. They live in the knowledge that they are at risk of developing leukemia. The origin of leukemia comes as a result of acquisition of new genetic abnormalities, and the presence of such genetic lesions would infer the transition to leukemia. And this process is really broadly termed as the leukemia genetic switch. Currently, when patients are diagnosed with leukemia, they're often late in the disease course, and despite the best treatment we have, the prognosis is still pretty poor. We do not have a test that could detect and predict this process early on. As a result, prevention is not possible. This is what our project is about. We believe our novel innovation and invention holds that right to detect and predicting this leukemic transition early on. Allow me to introduce you to our groundbreaking invention called Immuno-flowFISH. Immuno-flowFISH is a single-cell genetic method that could analyze hundreds of thousands of cells in one test. It can detect new genetic abnormality even if only 1 in 100,000 cells has that abnormality. This really holds the promise, we believe, in detecting that leukemic switch really early on. Our test puts 3 very important information all in one test. The first is the morphology on the far left. The second is the immunophenotyping, which is the protein expression of the cells coding in green, purple, and red. They really tell us the type of cells, identify the cells that we are actually analyzing. And the third, which is also the most important one, is the genetic results, where in the first 2 rows, you would see that there were 2 normal copies of gene. However, on the 3rd row, we could actually say that we have a cell that is malignant B lymphocyte that carries 3 copies of the chromosome 12. This is the power of our invention. And this is a WA invention. Our team members are proud inventors of this technology, and we have won the Eureka Prize in 2018 for the innovative use of technology. We're progressing this technology to this very unique piece of work in that we will study 100 patients with chronic bone marrow disorders. We will use Immuno-flowFISH to perform early and deep evaluation of clonal cytogenetic changes in single cells. We have studied a few patients with chronic bone marrow disorders with our Immuno-flowFISH technology. One of our consumers has a bone marrow that's overactive. The picture in the middle and the left is from her bone marrow biopsy. The gallery down here is her Immuno-flowFISH result. As you could make up, there is 2 normal copies of genes right here. However, in the second row, you probably could make out that one of this copy is missing. And we believe this is of great importance because this is suggesting that she is progressing to leukemia. Our vision and our aim of this project is to really make an impact for patients like her, in that using Immuno-flowFISH, we would like to go deep and go early for those patients in detecting the leukemic genetic switch, thereby predicting the leukemic transition. With that, making early intervention possible and potentially preventing full-blown leukemia. Our innovative work would have impact for patients, for Royal Perth Hospital, for WA, and globally. For patients, it would mean a paradigm shift from the current passive monitoring to active monitoring. This is not a unique challenge that we face in WA. This is a global challenge. And in this world-first strategy, our finding will be novel and it will have impact globally. This grant will also be a great investment for cancer research at Royal Perth Hospital, in WA, and certainly for this amazing team. I'm really lucky to be part of this amazing team. Our team made up of early and mid-career cancer researcher, mentored by world-renowned hematologist, clinician, scientists. We work across different institutions and research centers, making this a WA-wide collaborative project. In closing, I'd like to extend my deepest gratitude to Royal Perth Research Foundation, as also WA-FHRI. Our team and I can't wait to get started. We look forward to giving you plenty of regular updates about how we're progressing as we will to our consumer partners. Thank you.